Good afternoon, class. Thank you. You can sit down. All right, today after we look at the homework that you were asked to do in the last lesson, we are going to look at quadratic models. All right then, but first let's look at question 1 of exercise 3.2, which is the homework you were given. All right, draw up a table of values for y equals 6x minus x squared, for minus 1, 2, for x between minus 1 and positive 7. All right, if you plot the graph correctly, what value of x gives the axis of symmetry? Kila, what value of x gives the axis of symmetry?
3. X is 3.
X equals 3. Good. What is the maximum value of 6x minus x squared? Lester?
9.
9. What are the solutions of the quadratic equation 6x minus x squared equals 0? Siegfried?
X equals 6 or 0.
X equals 0 or x equals 6. Right, that's question 1. Question 2, you have to compile a table of values for the quadratic function y equals x squared plus 3x minus 4 for minus 2 to positive 2. Okay, let's just, Rita, you have to call out the y values from minus 5 to, when x is from minus 5 to positive 2.
X equals negative 5, y is equals to 6. When x equals negative 4, y is equals to 0. X equals to negative 3, y is equals to negative 4. X equals to negative 2, y is equals to negative 6. X equals to negative 1, y is equals to negative 6. 0, y is equals to negative 4. 1, y is equals to 0. 2, y is equals to 6.
So is this supposed to be negative 4? Okay, if you've got the correct table of values, you will also plot the correct graph. What is the equation of the axis of symmetry, Megan?
X is equals to negative 1.5.
X equals negative 1.5 is correct. What is the minimum value of y? Boromir.
Y is equal to negative 6 and a quarter.
Negative 6 and 1/4. Correct. From the graph, solve x squared plus 3x minus 4 equals 0. Natasha?
X is equals negative 4, x is equals to 1.
Okay, good. You were told to plot the graph of y equals minus x squared minus 3x plus 4. What do you notice about this graph? Jake?
It's the opposite of the first graph. It's the opposite of the first graph.
Okay, it's the opposite of the first graph. The first one is upright, the second one will be upside down. The x intercepts are exactly the same. The y-intercepts are different, they're opposite. All right, then number 3, you are to plot the graphs of y equals minus 2x plus 2 and y equals negative x squared plus x plus 6 from minus 3 to positive 4. Okay, I want the table of values for y equals minus 2x plus 2. Daniel?
When x is negative 3, y equals 8. When x is negative 2, y equals 6. When x is negative 1, y equals 4. When x is 0, y equals 2. When x equals 1, y equals 0. When x equals 2, y equals negative 2. When x equals 3, y equals negative 4. And when x equals 4, y equals negative 6.
Okay. Good. For y equals negative x squared plus x plus 6. Margaret?
When x is negative 3, y is negative 6. When x is negative 2, y is 0. When x is negative 1, y is 4. When x is 0, y is 6. When x is 1, y is 6. When x is 2, y is 4. When x is 3, y is 0. And when x is 4, y is negative 6.
Okay, those are the table of values for y equals minus 2x plus 2 and y equals negative x squared plus x plus 6. And if you've got the table of values correct, you will also get the graphs correct. Okay, what is the axis of symmetry? What is the equation of the axis of symmetry, just for interest? By looking at the table of values or by looking at the graph that you've drawn for y equals minus x squared plus x plus 6. Geno, what is the equation of the line of symmetry? Any idea from your graph?
Y is equals to 6 and 1/4.
Okay, that's why the axis of symmetry will be, it's the x coordinate. X equals a half, okay. It's between x equals 0 and x equals 1. So it's a half and 6 and 1/4. But the axis of symmetry is x equals a half. Okay, state the points of intersection. Geno, that was supposed to be your question. State the points where the graphs cut each other, where the line cuts the parabola.
First point, negative 1 and 4. Second point, 4 and negative 6.
Okay, 4, negative 6 and 1 and negative 1 and 4. Okay, if you have a look at the table of values that you have drawn, okay, minus 1, 4 here, and it's also here. 4, negative 6 is here, and 4, negative 6 here as well. You can also tell from the table of values what the points of intersection will be, because the y and x coordinates will be the same. All right, solve the equations simultaneously. Gabriel, what are the solutions to the two equations?
X equals to minus 1 and 4.
Any others? You just found one. You've got one, a minus 1 and 4. George, is there another point of intersection where the line cuts the curve?
Four and negative 6.
4, negative 6. Okay, Peter, it says for part D, compare your answers in C and B. What do you notice about the answers in C and B? Look at your answer, or the answers that Geno gave and the ones that Gabriel and George gave.
The points of intersection is same.
As the
It's the ones solved simultaneously.
Okay, the points of intersection are exactly the same as the solutions when you solve simultaneously, which means if you are asked to solve two equations simultaneously, you can actually plot the graph, and where the graphs meet or intersect each other, that will be the answers to the simultaneous equations as well. Like you plotted minus y equals minus 2x plus 2 and y equals negative x squared plus x plus 6. The points where they meet is exactly the same as the solutions when you solve simultaneously. Okay, so if you are asked to find the point of intersection of two graphs, even without plotting, you can also solve simultaneously, and that will be the points of intersection of the two graphs. There will be the points where the two graphs intersect each other. Okay, you actually won't do a lot of those this year, but next year in grade 12, you will do a lot more. Okay, then that brings us to the next section, which is quadratic models. Okay, just like there are linear models, there are also quadratic models. Those are graphs that you can also draw from experiments. Okay, like question 1 on the screen, I would like you to draw up fill in the table of values that's on the screen. It's also one of the questions on your worksheet. It could be question 1. On the exercise is the exercise 8.5. I'd like you to fill in the table of values and see if you can plot the graph quickly, and then we'll answer the questions together. I asked you to do that already, yeah? Okay, good. The surface area of a sphere is given by 4 pi r squared. Andrew, can you please give the values for A, given the values for R that are on the table of values?
When r is equal to 0, a is equal to 0. When r is equal to 0.2, a is equal to 0.5. When r is equal to 0.4, a is equal to 2. When r is equal to 0.6, a is equal to 4.5. And when r is equal to 0.8, a is equal to 8. When r is equal to 1, a is equal to 12.6. When r is equal to 1.2, a is equal to 18.1. When r is equal to 1.4, a is equal to 24.6. When r is equal to 1.6, a is equal to 32.2. When r is equal to 1.8, a is equal to 40.7. When r is equal to 2, a is equal to 56.3.
What? 60.3.
50.
Oh, sorry. 50.3. Okay, is the table of values correct according to the one that you've got? Okay. You will note that the values for R start from 0, which means if there is no radius, then there is no area as well. The sphere does not exist. Now, the values for R cannot be negative, because if they are negative, then the sphere actually does not exist, because R represents the radius of the sphere. So that's why we only start from 0. Okay, if you plot the graph, all right, it's something like this, if I'm correct. Okay, is that right? Yes. Okay, starting from 0, the values actually increase. All right, this is actually part of a parabola. It's on the one on the right-hand side. If you had the negative values, then the graph would go like that. But like I said, you cannot have negative values because R represents the radius. Okay, so if you've got that table of values, which is the one on the board, then you will also get the graph correct. Right? Part C. Use your graph to find approximately 1, the surface area of a sphere of radius 1.5 meters. Gabriel?
Surface area is 28.3 meters squared.
28 point? Did you say 28.3? 28.3, you all agree to that? Okay, correct. Number 1, C1. And then C2, Agnes. Find the surface area of a sphere of radius 0.9 meters.
The area is equals to 10.2 meters squared.
10.2 square meters. Pond relay. Part 3. Now you have to find the radius of a sphere that has an area of 30 square meters.
1.5 meters.
1.5 meters. That's 2 decimal place. Okay. That's correct. Now, 2 ways you can do this. You can answer these questions. 1, you can use the equation 4 pi r squared, or you can actually use the graph, and you're able to estimate the values of r and a from your graph. So you can check if you substitute, and also check with the graph whether your answers are very close to each other. Okay, now the next thing you are going to do is do question number 2. Quickly see if we can complete it before the bell goes. It's question 4 on your worksheet. All right, then let's just have a look at the question. The height of a ball which is thrown vertically upwards with a speed of 20 meters per second is given by h equals 20t minus 5t squared, where t is the time in seconds after the ball has been thrown and h is the height in meters. Okay, if you construct the table correctly, then it should be this. And if you draw the graph, h equals 20t minus 5t squared, you should have this graph as well. Oh, sorry, that's 20. And then we have to use the graph to answer these questions. Okay, you have to note, if you are asked to use the graph, then try and use the graph that you've drawn and just check whether you've got the same answer when you're substituting the values. Okay, what is the height after 2.5 seconds? 2.5 seconds? Garonamo.
11.3 meters.
11.3 meters? 2.5. I think that's a bit too low. Has to be greater than 15. Ponrele.
18.8 meters.
18.8.
8.
Okay. Note on the graph 2.5 will be between, 1. What did I do? Okay, that should be 2. Okay, 2.5 will be between 2 and 3, so it should be above 15 because when t is 3, then the ball is on its way down and it's going to be 15 again, so it should be more. Right, so 18.8 is correct. Part B, Miriam, find the time at which the height of the ball is 12 meters.
0.8 seconds.
Okay, 0.8 seconds. All right, note there are actually 2 times when the ball is 12 meters, when the ball is at a height of 12 meters. Note the ball is thrown up and then it comes down again. So on its way up, it's 12 meters above the ground, and then on its way down, there's another 12 meters here. So there are 2 times. If you're answering from the graph, it will be here, which is 0.8 seconds, but another time is also here. It's after 3 seconds. That's when it's on its way down. So what is it? 3.3? 4? 3.3 or 3.4? Check. Or is it between 3.3 and 3.4? Check if you've used the grid, you will estimate this correctly. 3.4 or 3? 4? Between 3 and 4? Okay, 3.35 then. We'll make it 3.35, between 3.3 and 0.4. So 0.8 seconds or 3.35 seconds. All right, just note again, 12 meters, there are 2 times. One when the ball is on its way up and one when the ball is on its way down. What is the maximum height reached by the ball? Dan?
20 meters.
20 meters, you can tell from the graph, that's the maximum height. Then the ball goes down again. When does the ball hit the ground? Velma?
It hits the ground after 4 seconds.
After 4 seconds, good. At this time when t is 0, it is still on the ground and not being thrown up again, so it hits the ground here. If you wanted to use the graph to find the time when the ball hits the ground, if you wanted to use the equation, then what you have to do is to make h 0. So you will solve 20t minus 5t squared. In case you want to check the answer. There will be 2 answers. One is going to be t equals 0, That's because the ball is still on the ground, and 1 is going to be when t is equal to 4. Right? You will have to accept where t equals to 4 because that's when the ball hits the ground. Okay, for homework, you are going to do, I think, 2 questions. Question 3. Find the question on your worksheet that talks about a chicken run. Right, that's question 3 on the screen. And then the other question is question 4. This one is about the perimeter of a rectangle. Okay, there's another one, the one that talks about the equation after the equation of the height after the cricket ball has been hit by a batsman. That's question 5. The questions for question 5, and that's it. Okay, 3 questions only for homework. The keyword to the pilot teacher is models. Good afternoon, class. Thank you.
National Education Week 2003.
Join the Department of Education this year in celebrating the National Education Week from the 6th to the 10th of October 2003 with the theme
Relevant Curriculum for a Better Future.
Kisim Save Long Come Up in Good Plus in Long Time Behind.
Mauri momokani ai diba tahua vaira ai, mauri namona noholaya totona.
Our reform curriculum promotes Papua New Guinea race. National Education Week 2003. Relevant curriculum for a better future.